Imagine standing in a waterlogged green farmland, surrounded by overflowing rice paddies. Now imagine standing in a dry, windswept desert of golden sand. Take a look at this map. You might assume those two extremes are separated by a continent, but the lush river valleys of the northern plains and the scorching Thar Desert sit just a few hundred miles apart. To understand how these environments coexist, we must follow the movement of water through the subcontinent. That journey begins high in the Himalayas. River systems like the Ganga and Brahmaputra are fed by melting snow cascading down steep, rocky slopes. As gravity pulls this water downward, rivers act as a natural conveyor belt. The current scrapes silt, sand, and clay off the mountain. Reaching flat ground, they slow down and drop this sediment, forming alluvial soil, a nutrient-rich bed of earth. This chart of green fields shows how that soil translates into survival. The high fertility of the ground allows for high agricultural yields, supporting enough rice and wheat to feed millions. In the northern plains, the reliable supply of mountain water and fresh soil creates a landscape that supports some of the most densely populated settlements on the planet. If we follow those rivers to their final destination at the Bay of Bengal, their momentum finally stalls as they meet the ocean. This is the creation of a delta. When the slow-moving river sediment meets the push of the ocean tides, the water is forced to fan out into an extensive web of channels. This is the Sundarbans. It is a world of brackish, waterlogged mud where the flora has adapted to survive. The mangroves here have evolved specialized breathing roots that stay above the surface even when the soil is submerged. At the edge of the continent, the meeting of river and tide creates a landscape defined by shifting mud and continuous biological adaptation. But move westward across the continent, and the lush plains end. The expedition stops abruptly at an ancient, rugged mountain ridge that cuts through the land. These are the Aravalli Hills. They are among the oldest mountains on Earth, and they act as a geological shield that blocks the moisture-heavy monsoon winds. This illustrates the rain shadow effect. East winds hit these peaks and are forced upward. The air cools, dropping all its rain on the eastern slopes. By the summit, the moisture is gone. Only dry air flows down the western side. Geography has created a physical divide. By stripping the moisture from the wind, the Aravalli Range sets the western boundary of the desert. West of the Aravallis, you enter the Thar Desert. Here, the temperature fluctuates wildly, baking through the day and dropping toward freezing at night. This region is arid. With almost no rainfall to sustain complex plant life, the earth is left vulnerable to the wind. Without trees or grass to anchor the ground, the wind becomes the primary sculptor of the environment, constantly shifting dry earth into towering formations. Unlike the plains built by river water, the Thar is a landscape built by wind and governed by the rules of scarcity. This contrast shows the difference between a lifestyle built on agricultural abundance in the north and one built on survival in the desert. In the desert, civilizations engineered architecture specifically to manage scarcity. They built these intricate stone stepwells to capture and hold every drop of seasonal moisture that reached the ground. These fortified cities were constructed almost entirely from the dry materials of the earth, using the desert's own rock to build thriving urban centers. From the fertile river plains to the rain-shadowed desert, geological features like water systems and mountain ranges determine how resources are gathered and how cities are built. To understand why these cultures live the way they do, you must first understand the geography of the land they stand on.